All right. Um, Julie, if you're still there, thank you. I think you set me up perfectly for the start. Um, so, uh, oops. So I'm here to talk about full stack data science, and you know, uh, hopefully, in the context, that's not a first world problem where you have a fully scaled business, but if you're a person with an idea and you want to start a data science business, or you have a scaled company where you want to implement data science practices, where do you start? I'm going to share with you some of the things I've learned sitting in, VC startup board meetings for the last 5 years, and kind of what the expectations from a data science team is evolving to. But before that, let me tell you a little bit about myself. So, by training, um, I've been doing computational and theoretical research between physics, biology, and chemistry. That's my original training. I have a PhD. I was a postdoc for many years doing bioinformatics work. So that's when I actually switched from Python to R as I found out about the bioconductor ecosystem. And after that, after being an academic, I switched over to the financial services industry. I worked for a startup out of LA. Um, in the debit card industry, which is originating bank accounts for people who are uh, deprived of any financial services. And from there, I've moved on to the credit card industry, where I focus much more deeply on the modeling side for underwriting models, risk models, churn models, and so on. Looks like my presence here has an uncertainty principle attached to it. Uh, is this a problem? Sorry? I have to use AC power? I do. Excuse me, guys. That works. Thank you. All right. And most recently, as I was saying, I work for a credit card company. It's a startup. Uh, should we solve for this differently? All right. I think this might have been the issue, so I got rid of that. That should be fine. All right. Let's give it a second. Oh, no. All right. Well, the good news is there are more people from the other talk, so welcome in, folks. Um, and this is the redux of my talk. Hopefully, there'll be no uncertainty about this. So, as I was telling you, I'm currently chief data scientist at Deserve. Deserve is a financial inclusion startup, and I'll tell you a little bit about what we do. But basically, we're focusing on onboarding people into the credit system, which is very important in the US, when people don't have any prior history of using credit. So we focus on alternative signatures and proxies for what might be identifying individuals with good potential to be financially responsible and issue credit cards to them, train them to be responsible with the right behavioral nudges, and then make them kind of healthy members of that ecosystem. So this talk is not about that. If you want to learn more about it, there's an NVIDIA AI podcast where I talk in detail about some of the models and the challenges there. But I'm going to leave you by saying that we're pretty proud that for a company of about 35 people, 20% of whom is a full stack data science team, we just got chosen by Time Magazine's Money section to be the best student credit card in the US. So, like I said, this talk is not about either me or who I work for, but it actually started from a Twitter conversation where when I joined Deserve, I was starting to hire a data science team, which is something I've done twice, nearly thrice in a row so far. And I tweeted out saying, hey, you know, I'm trying to build my second data team where we're using R in production. And there was a lot of surprise and delight around that. For people who are from the Bay Area, you probably know Gabriella. She's a very active member of the R community. And that, you know, started us off thinking about, you know, can we take R beyond what it's perceived to be, which is a domain-specific language for statisticians and modelers. On this talk, I'm going to focus kind of what I said earlier on what the evolving needs of a data science team are. What I mean by full stack, I'll use kind of a software development analogy to go through that. At least for early stage startups, I personally believe R is marginally better than Python, although my team, as you saw on the last slide, is completely bilingual. We speak R and Python. So I'll go through some examples of how, if you're starting from scratch, you can set up a full stack R-based data science environment. I may or may not get time to go into good practices around R, but it will definitely leave people here who are thinking about starting teams with a kind of buy versus build equation to think about. Before I proceed, how many people here are in startups that are less than 40, 50 people? Just a handful. How many people currently don't have data science teams? Again, a few people. How many people have written even a single line of R code? Yeah, nice. How many people consider themselves to be kind of full stack data scientists? Oh, there's 3 or 4 unicorns in this room, great. So that's super helpful. Maybe we can keep some of the R good practices for the Q&A. I know it's lunchtime. I'll try to recover some time, go as fast as I can, and leave a longer gap for Q&A so that people who are hungry can head out. So this is kind of my view from the past 5 years of being in VC meetings and boardrooms of what the demands are evolving out to be for a data science team, right? Especially in the Valley, everybody wants to say they're doing data science. I know there are many more phrases that say that in a better way. At the same time, data science is perceived by different functional units of the company in different ways, right? The operations team might say that, look, I need you to take data, oh, we have some promotional marketing that's not a production feature, but needs to be implemented, and the data science team has to help with that. There's, especially in the financial industry, which is highly regulated, the compliance team thinks data science should be helping them make sure that we're doing things right by the book. A lot of data science efforts do go into marketing. Lead scoring is a very classic example for financial services, where you only want to send a mail packet to people who have a high propensity score for being approved or desiring your product. There's plenty of marketing optimization in terms of real-time algorithms that make bids for you on Facebook and Google and kind of all the API-based marketing platforms. And finally, technology and product themselves are consumers of data science, right? The most prevalent example is A/B testing. On the product side, a desire to go beyond what services like Optimizely might offer, so that you can have multi-step, multivariate testing and reporting on that. And typically, a data science team is invoked for that. And finally, last but not the least, the expectation from any new company is that its reason to exist is what it's doing with data differently. That data science, in my view now, is also a vertical, and the function of that vertical within the company is to constantly curate new intellectual property that will always differentiate you in the market, right? So with that view, if there's one thing you take away from the slide, it is that if you're building a new data science team, you should think of it as an IP vertical, and also as a service provider laterally, who's developing good practices for testing, design of experiment, and also curates unique learnings to our system and our context, and provides that as advantage to the company for its success. And if you're a startup, success is basically survival. So if you can survive 3 or 4 years and still be a business, then you've kind of made it. You're the 1% group. So there are a few considerations. When you start a data science team, you can't go to a product team and say, hey, give me some engineers. I want to develop these 20 additional features that my modelers want to test out. In a startup, that really doesn't, that fungible resource doesn't exist in a product team. So there's a need that generates for you to consolidate everything you want to be done into a single team that is independent and self-sufficient. And that's what I've tried to call a full stack data team or a data science team. And the moment you acknowledge that that's what you want to be, you have to be ready for ad hoc requests of data that's important for the business, which is survival for startups. You have to communicate properly that there is a research arm to your function that has unpredictable timelines. And in general, in a startup environment, you need to have a pretty fast cadence around it. And the team, at that point, becomes responsible for effectively maintaining a source of truth for the entire organization. And building tools, just like Julie was mentioning, where people can self-service that source of truth in easy fashions. And then kind of the differentiated value that the team provides is building and curating new IP. So with that, let me kind of dive into what full stack means to me. This is something I've presented for the past year and a half. I haven't got any serious pushback. So I view full stack almost like a SaaS service views full stack, right? One of our sponsors for this meeting for Crunch is TransferWise. They're a financial business. So for them to be an effective web service that is constantly serving their entire customer base, they need something on the web, possibly in the cloud, which is DevOps. They need a state store that stores who are their customers and who are they sending money to. And then there's a layer, the middleware or the business logic backend, as it's traditionally called. That's imposing business rules like, okay, if somebody's in this table, they're a sender. If there's somebody in this table, they're a receiver. And if somebody just signed up, they cannot send more than $500. And if they're sending it to Hungary, maybe that threshold goes up or down. So there's that entire layer of business logic. But it's inefficient for a company to maintain business logic in multiple places, right? If you have a mobile phone and you have a web app or some kind of offline practices, you want that functionality to be stored in one place and to be available in an agnostic way across platforms. And that's what most businesses do. If you're a web-based or SaaS business, you expose APIs. And then the consumers of those APIs are the front ends, which is your mobile front end, your web front end, it could even be a Google Sheet reading data from an API. Those are all front ends. And finally, the service doesn't stop with those front ends. It goes beyond that. So people are communicating with you that, hey, by the way, your transfer to person X actually reached them, and I'm going to send you an email or a push message. And that final last mile of engaging the customer is also a part of that full stack environment. So hopefully in the next 10 or 15 minutes, I'll try to convince you that most of that necessity, and these are kind of the technologies that are used to fulfill those necessities also exist for a data science team. So a full stack data science team should be able to create its own pipelines, its own hardware, because nobody else has a stake in new engineered features. Store those engineered features and so on. Create a backend, which is a business logic of what metrics are defined in which way, and serve those metrics for consumptions by the web stack, the mobile stack, and other internal consumers. And finally, also go the last mile in delivering that information in an actionable way, right? So you're running some kind of a fancy anomaly detection algorithm, send an alert, and send an alert through the channel that it's most likely to get consumed, like a Slack alert or an SMS, which people will pick up. So long story short, I want to convince you that R and the ecosystem of R and the packages and kind of the containerized flavors that are available with that can more than suffice for the first few years of a business in terms of retrieving external data from marketing platforms and so on. Collecting data, processing it, storing it somewhere, analyzing it, running predictions, both in batch and kind of in memory through Spark clusters and connectivities, generating APIs that can be consumed by other services, and also going the last mile and informing people through shiny dashboards, as we saw, just simply spitting out Google Sheets or richer reporting in a format that's most consumed by financial services in the US, which is like a spreadsheet, right? So all that is possible. This slide is super heavy. My intention is not to go through all of this, but just try to remember this. Slides are going to be available later. What I've highlighted in dark on the right-hand side are open source packages related to R and made by the R community that allow functionality in each layer of this full stack. So Rocker, for example, is a community of different flavors of Docker containers with R and Shiny, with R and Spark, and so on. And it's as simple as running that image for you to have that functionality. There are very good database connectivity packages for different types of databases. very good client libraries for modeling platforms. We have easy transitions from writing an R function that does something to it becoming a JSON API through OpenCPU or R Apache. And probably the easiest transition from a functional data discovery to a visualization of that data discovery through Shiny. And there are obviously integrations with HTTP methods that allow you to ping APIs like Twilio or even like Slack in order to disseminate the information and the intelligence that's been derived. What I want to distinguish before I move away from the slide is, just like a product SaaS platform has the goal of making a scalable, engaging service, the new goal, full stack goal, at least in my mind, for a data science team is to have scalable, actionable intelligence that provides either optimization or a decisioning service. And I mean, most of these things are in line with what Julie said, but I'd like to convince you that this one technology can do most of that. In addition, R probably has two major things going for it. It came from the domain of statistics, so by default, you get a lot of richness in statistical methods that you could just turn on. You can prototype a lot of models really fast. And as I said in the last slide, and you can go from a discovery to a reactive, interactive dashboard without knowing a single line of HTML or front-end framework stuff. Obviously, there are some detractors. There's, very few people think of R in this mode, and so there are very few developers. If the best developers are sitting in one or two geographical units, either associated with RStudio and that environment, or probably in Europe with another group. And there's still some minor issues when you're dealing with very large data around memory management, but most of these can be circumvented. So how do we go from that realization to building the stack, while being mindful of who the final consumer of that stack is, right? As a small startup, you have to hire one person first and make them useful, powerful, and then grow the team out. So your ideal consumer just wants to do this. Like, give me an IDE. When I push to the IDE, things happen by themselves, right? So you have an IDE, and what you're trying to generate is an automation stack that goes from code to building the necessary containers, and you could do that through Flotilla, or you can do this through GitLab pipelines that automatically deploy containers to ECS. And, you can engage for machine learning, H2O or Steam that allows you to press a button and generate an API off the model that you just built. And similarly, you push code to GitHub, and it becomes a Shiny dashboard that's already in production and containerized and so on. So I think all of this can be done. And it can be done by first realizing what are the roles and functions you want in that stack. And most of this is custom to your business case if you're building a new startup. So you want some way to connect to the outside world. In the financial business, this is necessary because you have a lot of data partners, and you have to send some monitoring data to the bank, or you have credit bureaus from which you might be pulling data or updating data and so on. You need a scheduler that reacts to code pushes, but also does a few things on schedule because people are expecting it on schedule. If you're doing heavier computation, you need kind of the soldiers and the workers. You need your own internal storage, and a kind of separation of resources between generating the model and actually implementing and productionalizing the model, and a layer for reporting. And 5 out of 6 of these are available as Docker containers already. That means you can go home today, look for those containers, and turn them up on by tomorrow and play with them. And for storage and pipelines, I would say, R even has support for Kafka. You can generate producers, consumers, and Kinesis. Again, you can do similar things there. And it allows you to do pretty much everything you've heard about at this conference um, from a single language interface and IDE. And that's super powerful. Uh, Maybe this is overkill for this conversation, but if you had to start from scratch, basically you need three layers in the infrastructure you generate on AWS. You need your data sources, and your business determines what your data sources are. You probably have a staging and a production environment for your data science. And these could be 2 or 3 EC2 instances. If you're planning to use a lot of Shiny, then it could also be a cluster that services ECS or Docker containers as ECS. So you have scalability, auto scaling, and all those features on ECS. And then, like I said earlier, you want that your transformations and your intelligence that has been built to be stored somewhere, which is your source of truth, and hopefully the source of truth for the entire company. And you can do that through S3, Amazon, and so on, and other tools available within AWS. There are similar and equivalent tools available on Google Cloud services and so on. And just to give you a sense of the types of systems are built and fully functional in production, the Bastion scheduler would be running R and Jenkins because it's still small and we don't have first world problems where we have enough people to build our own platform. The worker would be running R, and it's invoked by, let's say, Jenkins, which is running in multi-node mode. The modeler is running H2O with all the necessary hookups in R, and we containerize Shiny through ECS. So that's kind of one way to do this, but there's obviously a solution for every business that might deviate a little bit from this. So with that, I'm going to give maybe 1 or 2 examples of workflows we have, not exact workflows, but types of things that have been done before, both in terms of building pipelines, and these are just simply with R scripts in Jenkins, and building kind of visualizations, because at the end of the day, a lot of decision making is based on visualizations. So, for example, you push some code, which is a Shiny app that you develop locally on our studio. You pushed it to Git. There's, by the way, Git also purchased a pipeline solution recently, and they announced that they're going to be building similar direct pipelines for containerization. So whether you're on GitLab or GitHub, it doesn't matter. You'll soon have pipeline capabilities. You can deploy to a container. The container lives in a VPC. That's your development environment. And if you write the code right and the proper API hookups, anytime somebody's playing with it and causes an error, you can trigger a Slack message to your data channel, right? And so it's a simple development pipeline. It's a testing system that instead of sending test errors to some external platform that you have to pay for, you just send it to your Slack environment and you're done. Other production use cases might be, look, I want to optimize my marketing in a really high frequency way. You write an R script or a service that is constantly polling your marketing platform for spend data, cost data. It also polls your internal database, production database for conversions or sales data. And it's computing a trend metric that you can validate against the expected forecast models, and then either alert the people if something's going wrong or to actually increase the bids and spend more when things are going well. Right? So, and when there are exceptions, again, you can catch them, send them as an API call to Twilio and send an SMS, or an API call to services like SendGrid to send out emails. So all of this, again, can be done pretty easily within R. I think the power of Shiny dashboards has already been brought up today. What I want to kind of build appreciation for is that you can build complex propensity scoring by marketing channel type of dashboards in 2 weeks with one summer intern. It's that easy, and the intern didn't know how to code front ends, but this is like a completely reactive dashboard where you can drag and drop dates and you can select which channels you want to look at. And you get statistics on the fly, which is real-time statistics from various platforms. You compute a propensity score, and for each step in your marketing conversion funnel, you're saying, look, hey, there are blue zones based on your score and red zones based on which channel is bringing in traffic that falls off at a certain point in terms of quality, or positively or negatively selects for that quality. Like I said before, when you have A/B tests set up, you can also have automated R scripts or services that are checking progress. And this is actually something we do every time as part of design of experiment. You set up a test, and you also set up the reporting automatically to Slack, because R has good packages to integrate with Slack. And the two examples I've shown here is, the first one is something that's done pretty commonly in the financial industry. You never hot swap models, because there's a lot of compliance and regulatory overheads you have to pay before a model goes live into production. So the common mode of operation is you have one model running that's approved to be making decisions for you for underwriting, like who gets a credit card, who doesn't. And then you have 5 or 6 models that your team has built that is running in parallel, in shadow mode, as I call it. And you can generate a contingency table of how are the shadow models doing compared to the one that's in production. And then you could also have obvious A/B tests that are being reported and directly to Slack to the to the related stakeholders. So with that, I'm going to speed up because we lost time. I have 2 or 3 slides on for our users in terms of, look, how do I generate my MVP? And what are the things I need to put in the stack for me to go to being productive in 2 or 3 weeks? What do I put into my R package for this to generate ability up and down the stack for me? And also, I'll go over some good practices if you can make it to the R meetup later this evening. But I'm going to close out by saying, look, when you're small, as a company, 30, 40, 50 people, and 20% of your company is going to data science, a lot of expected out of this team. That you're expected to do exploratory analysis, generate intelligence. You don't want to be the guy who's only generating raw data and giving it to other people. You want your team to actually provide some layer of intelligence beyond that raw data. So for the ideal expectation on this team should be to build the tools for consumption of raw data, but also build intelligence on top of that. Predictions, obviously, batch, API, and also in stream for real-time evaluations. These are the expectations. And the skills that you typically require in the team, and these may or may not come from one person, is some back-end capacity. You should know the ecosystem, either on Amazon or Google, so on, how to build containers, et cetera. Some capacity as a data scientist, depth in statistics. I would argue if you have to hire one person, but get somebody who has depth in statistics if you're building a data science team, and then you can add on engineering capabilities or cross-train the person into engineering. As your modeling bandwidth increases, you want more and more specialization, but generally for very small startups, a group of generalists is better. And over time, when the workload on the team goes high enough, you also want effectively a PM within the team. Finally, because you're always going to have a mixed bag of people, this common goal and accountability of building scalable, actionable data services also needs to be enforced with the right common mindset within the team. I'll talk, again, in the R context, I'll give a few tips. And finally, if for the people, the few hands that went up that are starting their own businesses or their own teams, you know, generally speaking, if your business does not depend on the intelligence coming from a data science team, and you're, yeah, you just, the use case doesn't exist where you're differentiating on data, and you're mature enough that you can afford the resources, then generally it's a better idea to buy a platform or to, consulting services that will provide you the exploration that you need. There are downsides to that. You probably need some custom integrations with platforms or to hire engage niche consultants. And you might get locked in if this is viable into platforms and so on. On the other side, if you're a regulated industry like finance, healthcare, criminal justice, then you probably want to own that entire data stack because you want very, very tough controls around that. So that's a pretty strong use case to build. It's also, you need availability of good engineers and scientists to enable this. But at the end of the day, in the long term, your cost might net out to be a little bit lower. So we have 4 minutes to go, plus some Q&A time. So let me kind of leave with impressing on you again, maybe 2 or 3 takeaways from this talk. One is, if you're starting anew, you should consider data science to be an IP vertical in the company, as well as a lateral service across the board. You want, de facto, the team that is going to work most with the data to also maintain that source of truth for the entire company. As a full stack data science team, the focus should really be around building IP. And if you're not already committed to a certain technology, then the richness of our ecosystem is ideal for this, for the first few years of a business, going up to 100,000 customers, or if you're dealing with less than 100 million rows in your jobs, you can easily do that with R. And I think Alex from the previous talk had this question, are there really full stack data scientists? And I think the answer is yes. My view on this is, we need people who can work with systems and code and create models, and most importantly, have some empathy between these roles and within the team. And I've been more than lucky to find a few people, that I call our unicorns. They may not all be the glowing white unicorns as we see in fairy tales, but we get unicorns in all colors, and we kind of make a united colors of Benetton approach in our data science team. But pretty much everybody is cross-trained in every other function within this team. So I'll stop there. Thanks for your attention. Happy to take questions.
Thank you so much. So let's start with the first question. Why do you prefer R and Shiny over Python and Dash?
Good question. I think it is somewhat circumstantial because if your focus in building a team is to actually create more and more embedding of statistical practices into your decision making, then you're more likely to find good statistically trained people and the best and latest algorithms in R, because most of the academic community first develops and releases the latest algorithms in R. So when the number of heads in your team are small, you don't have the resources to have multiple people having separate functionality, then you choose the path of least resistance from that discovery of data to publicizing or generating internal consumers of that data. So right now, my preference is for R and Shiny. Like I said, the teams I build are completely bilingual. I don't have a very strong preference beyond a circumstantial one. Yeah.
Thank you. Arguably, R is not a mainstream language. How hard do you find it to hire people at sufficient quality versus quantity?
It's a good question. So there are, in terms of syntax, there are a lot of commonalities between R and Python, and even some of the packages that have like DSLs or domain-specific, package-specific syntax like data tables, and I think even tidyverse, but I could be wrong about that. They, those authors are generating equivalent packages in Python. So any IP or code that you generate in R, I find people who come from a Python background that are pretty like heavy developers, they catch on to it pretty easily. And over time, people who are trained statistically with an R background actually easily transfer over to Python. So I agree, it's not a mainstream language. At the same time, it's where you have a higher prior probability of a statistically trained person knowing R than Python. And from a hiring strategy perspective, it's actually pretty efficient.
Next one. How do you pick the optimal tools from the 10,000+ R packages available on CRAN and GitHub?
Yeah, it's a good question. Some of it is just experiential. It's trial and error. You know, there might be 5 different ways for you to do gradient boosting or 10 different packages to do that. A part of it is being at conferences where people are presenting benchmarks. I think there's some benchmark sessions this afternoon as well. And I think the use case typically determines what you end up using, right? For example, to generate the Slack bot that you saw on the previous slide, I had to go to GitHub to see if there was an existing integration or I have to build one. The barriers to building one are not super high. But there was a package, it was somewhat broken. You push a PR to it to fix the things you want to do and run it in production. And I think the diversity in the package ecosystem has pluses and minuses. The pluses are, for most of the things you want to do, there's something out there. So you don't have to recreate it. And the minus is, you know, there's a kind of a gluttony of choice, if you will, and you have to decide what's optimal to your use case.
Thanks. So why should a startup hire a statistician first instead of a software or a backend engineer if most business projects are solved with logistic regression?
So I would argue that if most of the problems in that business don't require much more than a simple linear or logistic regression, you know, even a tool like Looker that's plugged into your database and has some basic LookML functionalities is sufficient. It's only when a company feels it's sitting on a lot of data that contains latent information and knowledge, and the scale at which that knowledge can change the business is not being harnessed by the existing tools, that you really want to escalate to more sophistication. And I think that's probably not a very satisfying answer, but you know, it's when the 80% you have harnessed from logistic regression is not enough, is when you start building this kind of a team. Yeah. There are exceptions to that, you know, especially in Silicon Valley. There are lots of teams whose thesis for existence is that they're building some kind of a machine learning service or platform and so on, in which case you want to hire data scientists first, and they would be a larger component of your initial hiring phase. Yeah.
Statisticians are a new cool, right?
Well, I don't know. There's so much lack of truth in numbers going around that you know, having uncertainty bars around polls would be awesome as a good start. Yeah.
Great. Maybe last question. Is there any alternative of TensorFlow in R? How is it useful?
So I believe R has bindings and adapters to TensorFlow already. I think if you have enough data and a use case for deep learning, then you can access that through R. It's not a challenge. See, so there's no, you don't need an alternative in terms of finding other solutions. And in terms of utility, I think the utility is the differential utility of deep learning compared to what you're doing right now. That doesn't change, right? For the financial business in particular, because it's regulated, and you have to explain to regulators as well as your banking partners that, look, if I make a credit decision, I can actually tell you why somebody was approved or denied for that credit decision. That, because of that burden of proof, typically deep learning methods and kind of sophisticated neural nets are not used. You tend to use methods that are much more explainable. And yeah, obviously tree-based methods are quite explainable, and logistic regression, of course, yeah. So the utility is really, you know, it's based on the business use case. I know deep learning is being used pretty effectively for time series and deeper models when you have a lot of information about each individual. For example, churn prediction or prediction of attrition, or looking at multiple interactions or transactions of a certain person to say whether or not they're going to stop using your product or to take your money and run away or something like that. So where you have the richness of data and you're a scaled business, that's where it's useful.
All right, thank you very much for patiently answering all the questions.
No problem. Thank you very much.